everyone and welcome to Maths Club. So the past few weeks I've done lots of long multiplication and I'm going to make it a bit different today, and I'm going to do some trigonometry and I'm going to show you Pythagoras theorem. So Pythagoras theorem says that if you have a right angled triangle like this and you want to know one of the sides, then you can work it out using the other sides, because say this is A, this is B, and this is C. Pythagoras theorem says that A squared plus B squared equals C squared. So if you wanted to know C, you would just take the square root of this, or if you wanted to know B, you would go C squared minus A squared and then just take the square root. So that's a very handy way to find the third side if you know two sides and you don't know another side. So it's generally a very useful thing to know. So let me show you why Pythagoras theorem works. Now I basically took this for granted most of my life, and then I thought, well, if I'm going to demonstrate it, I better find out why it works. So this is a nice little proof I found on the internet. So this is a square and it has, each side is length C. Now I'm going to take the triangles we had before, which are A and B, and then I'm going to put this triangle in here like this. There we go. There we go. Right, I've just realised I've made a mistake, but not to worry. So cross this out. That's not C. This is C. Alright, let's keep calm and carry on. Right, so that's C, C, C. And then these are our little triangles. So you've got A, B, A, B, A, B. So basically the area of this square here is the area of this square minus the triangles. So what's the area of the big square? Well, it's A plus B squared, because each of these sides is A plus B. Now we know that A plus B squared is the area of this smaller square plus these four triangles. So we know that A plus B squared equals C squared plus 4 times the area of these triangles. So what's the area of each triangle? Well, it's A plus B, A times B divided by 2, because A times B would be the square, so you divide it by 2. So it's 4 times a half times A times B. So basically, if you rearrange that, well, that'll be, this will give you A squared plus B squared plus 2AB. This is 4 times a half times AB, which will reduce to 2AB. The 2ABs will cancel on either side, and it will leave you with C squared equals A squared plus B squared. So there you go, there's a proof of Pythagoras theorem. And just to demonstrate a few examples, a nice triangle to prove this with is one where you have 3 as the length of one side and 4 as the length of the other side, because it's easy to do the calculations. So in this side, you've got our unknown. So we know from Pythagoras that the unknown squared equals this squared plus this squared. So 3 squared plus 4 squared. Well, that's 9 plus 16, which is 25, and the question mark is the square root of 25, which equals 5. So that's a good example because you can square root 25 in your head without getting the calculator out. So also similarly, if you knew that this was 5 and you needed to know this one, you would know that 5 times 5 is 25 equals 9 plus question mark squared. So you'd subtract 9 from 25 and give 16, and then the square root of 16 is 4. So that's a nice example to use, just because you can square root all these numbers quite easily. So that's it. That's Pythagoras' theorem and a short explanation of why it works. That's all for now. Bye.